Welcome, children. The 300 turn primary of a transformer has resistance 0.82 ohm and the resistance of its secondary of 1200 turns is 6.2 ohm. Find the voltage across the primary if the power output from the secondary at 1600 volt is 32 kilowatt. Calculate the power losses in both coils when the transformer efficiency is 80%. This is the transformer, primary coil, and this is the secondary coil, and the number of turns in the primary is 300 turns and in the secondary it is 1200 turns, so it is a step up transformer. So the resistance in the primary coil is 0.82 ohms and in the secondary it is 6.2 ohms. The voltage across the secondary coil is given, it is 1600 volt, and the power output is given, it is at 32 kilowatt. Then the efficiency is 80%. Then we need to find the voltage in the primary coil across the primary coil and the current in the primary coil, the alternating current in the primary coil and alternating current in the secondary coil. Good. The path. Please remember NS by NP equals Vs by Vp. This is called transformer ratio. This is true for ideal and not an ideal transformer. Efficiency is not equal to 100%. So what you need to remember is Vs by Vp is not equal to Ip by Is. So to find the current, you have to go through the efficiency formula so that you will be finding the power loss in the primary. Good. Eta equals power output divided by power input. Then second formula is Ns by Np equal to Vs by Vp. Let us start one by one. The power loss, of course, we have to know the power loss formula, that is I square R. Solution. Power output equals Vs Is. From here we can find Is equals power output that is given, which is equal to 32 kilowatt. Vs voltage in the secondary is given, that is 1600 volt. Substituting these two values, we get Is equals 20 ampere. Let us keep it near the corner. Good. From this we can find what is the power loss in the secondary. So the power loss in the secondary is given by a formula power loss in secondary equals Is square multiplies R. The R is here is the resistance in the secondary coil. Remember that. So the value of Is is 20. So 20 multiplies 20 into Rs is 6.2 ohms. So that has to be substituted and multiplying, we get the power loss in the secondary equals 2480 watt equals 2.4 kilowatt. So good. Now let us find the efficiency P out divided by P in, 80 divided by 100. So we can say that the power out is 32 kilowatt, that is 32 into 10 power plus 3 divided by power in equals 80 by 100. From here we can go with power in equals 40 into 10 power plus 3, that is 40 kilowatt, because here one cipher and one cipher cancels, right? 1/8 goes how many times? It's 4 times, and you get 40 into 10 power 3, it is equal to 40 kilowatt. A simple calculation. So we have found power input power. So Ns by Np equals Vs by Vp. Substituting the values, we can find Vp, which is equal to Np divided by Ns into Vs. Substituting the value of Np, which is 300 turns, it's here, and Ns 1200 turns and Vs 1600 volt. We get, yes, it's also simple calculation. We get the voltage across the primary coil is equals 400 volt. So you can simply cancel this part, right? So look at here, this is 1 time, this is 4 times, right? This 4 is 1 time and here you have it is 4 times, right? These two zeros chops these two zeros. Good. So let us go for finding power input, that is equal to Vp Ip. So Ip equals power input divided by Vp. What is the power input? It's already we found that it is 40 kilowatt, it is 40,000 watt divided by 400. It is a simple division. So we get Ip equals 100 ampere. So as we found the primary current, we can find what is the loss, power loss in the primary circuit. Power loss in the primary equals Ip square multiplies R. Here the R, the resistance in the primary coil, right? That's equal to how much? 0.82 ohms. So 82 into 100, it becomes 8200. So it becomes 8.2 kilowatt. The power loss in the primary is 8.2 kilowatt. Thank you, children.